Right guys, something slightly different today. We're looking at a famous mathematical theorem that looks at the side lengths of a right-angled triangle and the relationship between them, called Pythagoras' theorem. Okay. Now the first thing we need to do is to be able to label a right-angled triangle. So the hypotenuse is the name we give to the longest side on a right-angled triangle. Okay, longest side of a right-angled triangle is the hypotenuse. Okay, hypotenuse. And we always label that C. Okay, so the longest side of a triangle, of a right-angled triangle, we always label C. Now, if you're struggling to see what the longest side of the right-angled triangle is, which normally it's pretty obvious, it's always going to be opposite the right angle. Okay? Now the two legs, the two other shortest sides of the right angle triangle, we label them A or B. And it doesn't matter which way round we label them A or B. I could quite easily have called that B and that A and that B as well. It wouldn't matter. Okay? But we label the three sides A, B and C. A and B are the two shorter sides, the legs. C is the hypotenuse, the longest side. Now the formula tells us that if we square the lengths of the two smaller sides and add them together, we get the same answer as if we just squared the longest side. Okay? Now this can be quite useful for finding missing lengths. So for example, if I wanted to know what that length is, and I knew what A and B, the lengths of A and B, I could square those, I could add them together, and I'd be left with whatever this is squared. Okay, and then I can undo that, I can square root it and find it. So we're going to look at some examples on how we can do that here. So, I've got an example, okay. Now, I am going to do all the working for this, okay. So I'm just going to move a few things around here. There we go. So, I'm going to write out this basic formula, okay. Squaring one of the shorter sides and then squaring the other shorter side and adding them together gives us the same answer as if we just squared the longest side. I'm going to label my longest side C. I'm going to label the other two sides, and it doesn't matter which way round I label them. So I'm going to fill in the bits that I know. I don't know C, so it's going to stay as C squared for now. I do know what A and B are though. So A is 8, so 8 squared plus 6 squared, because B is 6, is equal to C squared. So 64 add 36 is equal to C squared. 100 is equal to C squared. All I've done there is added these two together. And then if I square root both sides, I get C is equal to 10. Okay? Now guys, you've got a right-angled triangle here with legs of 5 and 12. Could you please use the same method as me to try and figure out what this is going to be, okay? You can use your calculator to do this. You only really need a calculator on your phone if you don't have a scientific calculator anyway. You will get a whole number answer for that, okay? So pause the video now and have a go at that for me. Okay guys, you should have had a go at that. I'm now going to go through it. So, label the longest side C, label the two short sides A and B. If you've called 5A and 12B instead, it doesn't matter, you'll get the same answer. Let's write out the formula. A squared plus B squared is equal to C squared. The squares of the two short sides have a sum that's the same as a square of the longer side. Fill in the bits that we've got. We haven't got C, so we leave that as C squared. Add them together, we get 169 is C squared. Square root both sides of the equation, we get C is equal to 13. Now guys, you might think that we're always going to get whole number answers for this, but that's not the case, okay? So, if we just flick to this page here, will it always give a whole number answer? No. Okay? Now, I've measured these out, okay? That's 3.5 centimetres, and that's 6 centimetres. This is 2 centimetres, and this is 4 centimetres. And I've used Pythagoras' theorem to work out what these lengths should be, okay? This length here should be 6.95 centimetres. And I created this ruler here because I left my ruler at school. And if you can see there, it's just less than 7. Okay, this dash here is 7, and that's just less than 7. So it works. 6.95 centimetres. For this one, we should get 4.47. Okay, I've done all the work in. I've missed out a few steps there because you didn't need to see all the steps, but I got 4.47. I'll measure it with my ruler that I made out of a pizza box, and if we line it up, it's 4.5 centimetres roughly there, okay? So it doesn't have to just involve whole numbers,